Good morning, everyone. This is Ms. McClellan here to tell you what I think you need to know about confidence intervals. Now, hopefully you have watched the other YouTube video that I sent the link for, so that has given you a good basic understanding, and I'm just going to give you some more. Some of this will be overlap, but that's okay. It's always good to hear things more than once. Okay, so confidence intervals. With the advent of Chapter 8 and Chapter 9, we get into the topic of inference in this course. Inference is what it sounds like, making inferences or inferring something about a population based on a sample. So in the case of confidence intervals, what we're going to use is a sample, and we're going to use that sample to estimate the value of a parameter in a population. Okay, so this section will cover these topics. This idea of a point estimate is something that sounds new, but it's really just the sample statistic. And the margin of error is what we're going to add or subtract to our sample statistic to come up with our confidence interval. So let's start with an activity. Suppose I was able to get to your calculator and store a value in your calculator. Your job would be to estimate possible values, and to come up with a specific exact value might be challenging. So instead what you're going to come up with is a range of values. This is what's called a confidence interval. So let's call the value I put in your calculator a mean. And the way that I did this, if I was actually able to do it, would have been to go to your calculator, enter the number 245, press the store key, then alpha divide, which stores this number as m on your calculator. You don't have to do this, but I would recommend that you pause this video and give this a try. And hopefully at this point everyone has a calculator. Remember, I sent two different ways you could get free calculators. One is Texas Instruments on your computer, free download of their software, and the other is the GraphingCalc app on your phone. If you have an iPhone, is now free. Okay, so we're going to enter this command on our calculator, and to do that we're going to first go to list, which is second stat. So second stat, and then arrow over to math and choose mean. And then we're going to put in rand norm, which is under math, and then scroll over to probability, number 6. And to put the m in, we now again have to do alpha divide, because that's where the m is, comma 20, comma 16. You put that in your calculator, you hit enter, enter, it gives you a value. So that value is going to be our estimate, our point estimate for our interval m. Our interval to estimate the value of m. All right, so what did we do with this calculator? It told us, we told the calculator to take, use a rand norm, sorry about that, let me start again. To take a normal distribution whose mean is m, whose standard deviation is 20, take 16 numbers randomly from that population, and then find their mean. Okay, so say that again. M is the mean, 20 is the standard deviation, take 16 numbers from a normal population and find their mean. Okay, so what did we get? Suppose we got 240.8, and this is the same number if you're reading in your textbook, which you should be doing, that they're using as the example in the textbook. All right, so some new terms. Point estimator, simply the statistic from the sample. Okay, we're going to use that statistic to provide an estimate of the population parameter. Okay, so the statistic is from the sample, the parameter is the value from the population that we want to know. And in most cases in the real world, we don't know population parameters. For example, what proportion of people in the United States today have the coronavirus? We have no way of knowing that, but we could estimate by using sampling activities. The point estimate is the value that we get when we take our sample. So point estimator is the statistic we're going to use. Point estimate is the value of the statistic. Suppose we got 240.8 from our example. That means the sample mean is the point estimator. So the sample mean is the statistic that we're interested in, and the point estimate is 240.8. Don't worry too much about this vocabulary. This will not really be something that you need to worry about too much. Okay, so If we got 240.8, is this value the population mean, mu? Probably not, right? Each time we take another statistic, another sample, we're going to get another statistic. So if you don't believe me, try that again. Just hit enter on your calculator again, and you'll see you'll get a different number. And do it again, and you get a different number, and you get a different number. What would the sampling distribution of the sample mean x bar look like? Well, remember what a sampling distribution is. Whoops, I spelled that wrong. If we take every possible sample of size 16 from a population whose mean is m and whose standard deviation is 20, we would get a normal distribution with a mean of m and a standard deviation of 20 divided by the square root of 16, which would give us 5. Now, why can I say that this is normal? Because my population was normal to start with, right? I took these numbers out of a normal distribution, okay? So I took 16 numbers and I found their mean. So now the sampling distribution of the sample means, okay, of the sample means would have a standard deviation of 20 divided by the square root of 16, which is my sample size, which is 20 divided by 4, or 5, okay? So we started with a distribution that looked like this. We don't know what mu is. That's what we're trying to figure out. Okay, standard deviation is 20. So we have a distribution, the mean plus 20, plus 40, plus 60, minus 20, minus 40, minus 60. Okay, now our sampling distribution of x bar, we have a different standard deviation. This standard deviation becomes 5. So this distribution, this picture isn't a very good one, would be much narrower. So instead of going plus or minus 20, we're going plus or minus 5 here. Okay? In repeated samples, x bar would be normal with a mean of mu and a standard deviation of 5. Remember our 68, 95, 99.7 rule from way back when? Tells us that 95% of all samples of size 16, in all those samples, the sample mean would be within 10, which is 2 standard deviations, 10 is 2 times 5, within 10 of the true population mean, okay? So, sorry about this thing here. Let me see if I can move this around a little bit. So you see here's our population mean, plus or minus 10, 95% of all samples of size 16 would have an x bar value from the true population minus 10, the true population mean plus 10. Now there's an applet, confidence intervals applet, so let me pull that up, and I'm just going to pause this for a second. Okay, I'm back. All right, so here we have an applet that's going to show us what happens when we choose sample after sample after sample. Okay, so my confidence level is set at 95. I want to be 95% sure that I'm actually capturing the true value of the population mean mu. Okay, now this app only allows me to do samples of size 20 or 15, so I'm just going to leave it at 20, even though in our example we had a sample of 16. So let's see what happens when I hit sample. So you can see here these little dots. These are the values in my sample. Take all these values, okay, and find their mean, which is this dot right here, and then a 95% confidence interval, which we'll learn how to calculate later, is this bar here. So from here to here is the confidence interval that would be calculated from this sample. Okay, I'm going to do another one, and you see that I'm getting a different mean and a different confidence interval. I can do this over and over again, okay, and then I can do 25 at once. Now you can see here that every one of these confidence intervals has captured my true mean, mu, okay? Now, is that always going to be the case? Let's try 25 more. So now you can see down here, whoops, we missed one there. So I'm up to 55 samples and I've missed one. All right, I'm going to hit, or actually it says I've missed 2. I don't know where the other one was. Oh, no, I'm sorry, 98% of 55. Okay. Now I missed another one, and I'm just going to keep going, doing more and more. It's just loading them down further. So far I've taken 105 samples and I've hit 97 of them. I have a 95% confidence level, so 97 is a little bit higher than 95. If I keep doing this, this is going to close in, you can see right around 95. So 95% of the time, the confidence interval that is calculated based on the sample mean will capture the true value of the mean. And there's what we're talking about with confidence intervals. Okay? So here's what you need to know. If we know the value of the sample mean from one sample, we can estimate the value of the population mean. The sample mean will vary from sample to sample, but we can use any one of these values to estimate the population mean within an interval. So we start with our estimate and we add and subtract what we call our margin of error. And we're going to learn how to calculate that. It looks complicated, but it's really not that bad. Okay? How do you interpret a confidence interval and a confidence level? So a confidence interval, these words, in this course they always want you to use specific words. These words say what we want to say. In this case, we are 95% confident that the interval from some number to some number captures the actual value of the population parameter. So in our case, the mean that was put into the calculator. Confidence level is, in this case, 95%. So if we say we're 95% confident, what we mean is if we take many, many samples of the same size, about 95% of them will result in an interval that captures the actual parameter value. Now, what if we wanted a 90% confidence interval instead of a 95% interval? What would that look like? Well, you can see if we only need to be 90% confident in a normal distribution, that means we have 10% left on the outside that we don't necessarily worry about. So our interval is going to be smaller. All right? We would be less confident. We'd have a tighter interval, but we would be less confident that we actually captured the true value of our parameter. And so in general, the higher the confidence, the wider the interval. Think about this as fishing, right? If you're trying to capture a particular fish, if you just throw a spear into the water to catch the fish, you're not likely to catch the fish. That's just stabbing at a particular number. If you make a net, okay, then you're more likely to catch the fish. The bigger the net, the more likely that you're going to capture the fish. Okay, so that in a nutshell is what you need to know to introduce the idea of confidence intervals. And we're going to learn how to construct them. This slide looks really ugly and nasty. This is the general formula for calculating a confidence interval. The calculator can do all of the work here. We just need to know which formula to use, and we'll talk about that in our next presentation.